All set?
Yep.
All right. So, yeah, I'm talking about Ceph. Cool green player. Awesome. Makes me happy. This is me. I've kind of been around a while. Big from Wartburg College, math, computer science, and physics. That's the story, but I started out in physics, didn't like it, and of course, by then you get enough math, you might as well double major. So, been working here at DMAC for 20 plus years, doing networking, Cisco, all that kind of stuff. So I'm the guy that gets the line there that goes down. Been using Linux since '94. I think that was about a year after Linus first released the source publicly, so it's been a while. And I've been running a Ceph cluster, which we've been talking about for about 2 years now. Search back, and I signed up for their users mailing list September of 14, I think. So I guess almost 3 years. So just a few disclaimers. I'm pretty smart, I like to think, but I'm far from a Ceph expert. You know, when crap hits fan at home, it's like I'm searching the list trying to figure out what commands I need to run to fix this thing. So, you decide, oh, I want to try this out. It's like I'm the last person to talk to. I'll cover some resources later. That'll better help it out. And yeah, it's like I'm just touching of Ceph here, just to get understanding kind of where it is. You didn't want it, but there's so much you need to know before you actually go and start installing. But there's a lot of great resources out there. Yeah, the Ceph community is super excellent. There's a mailing list, the users mailing list. A lot of times people are like crap, my cluster is down, help me. And a lot of people want to jump in. And there's paid sports too, if you're running this for your business, your school, or whatever, they can help out too. So what is Ceph? Basically, it's a distributed storage system. How this differs from, obviously it's distributed, so it's on more than one host. Their only connectivity is basically Ethernet. No fiber channel. Could use fiber channel, but basically it's a standalone PC that runs Linux and some software and makes all your hard drives work like one. But it's designed for performance, reliability, scalability. It's not. It's kind of one of these products where people don't always post the numbers that they do because it's kind of they think it's kind of proprietary secrets that want people to know and just tell them what they're doing. But in the release notes, they say that they've tested this on a 10,000 disk cluster, and if all 10,000 of the systems for 10 terabyte hard drives, it's 100 petabytes. So it's more storage than pretty much anything Google or Facebook uses. It's all open source. If you really felt like it, there's a file on the GitHub that you can look at. Mostly GPL2, there's some GPL2 and GPL3 bits, and documentation if you count. But I think even we said, have a slide about this, that Ceph was invented by this guy to save the wheel. I think I was out in California, different schools. I think it was like a PhD or master's dissertation, something like that. He went and found a company called Blue Tank and then Red Hot Blue Tank. So it really, if this was mission critical for a Red Hat or somebody, their support. But even there, since it's Red Hat, their approach to open source is that we're selling you support, not software. So basically, they say, here's this this version that has features, stuff that we're going to support. So you want different features, and you can go with the community open source edition. You know, but if you want Red Hat solution, you can run their version. And the only difference is that they're stick to a certain set of features and not the backward patches. So unlike other commercial companies, they're open source and has one set of features that pay money to get. It's not something that other source. Now it provides the core software provides object storage, block storage, and file services. Object storage, so basically key value storage. So you know, Redis or other things like that. Basically, you got a key. I think Ceph. I couldn't find the exact one, but a key is like 128 bytes of whatever you want to call it. So Ceph is just a blob. Objects. All I think maximum is 100 megabytes. But if that's bigger objects, you can change some tuning parameters, and you can go up to several gigabytes. And objects can come up from the minute. And once we get to the demo section later, we'll see a little bit of this in action. But even though core Ceph provides other features, it's all built on top of object storage. That's kind of what lays everything everywhere. So you get down to it, everything's an object, not keys. But as part of the core software, they provide block storage. Basically, taking a chunk of the storage you've dedicated to Ceph and presenting it to the client host, and it looks like a block device. So you can format it with XFS, X4, ButterFS, FAT, whatever the hell you want. As far as the Linux kernel is concerned, it's a block device. There's code built into the kernel that can do that too. There's also a user space fuse daemon, and if you get the right kernel version, you want to go with the kernel model. It's faster, and they're supportive of it. If for some reason you have to run a certain version of Debian with this kernel, but you want to run storage, you're doing the fuse system because the kernel driver is too old or something like that. And whatever Debian is. So it's slower, but it's easier for it to be updated in the kernel. But it's great for VMs. KVM has native support for it. So when you set up a KVM VM, which I don't think there's a way you can do it in GUI, but you get in the command line and the config files, you can say, point it to your stuff storage. Here's the name of this block device, and it's just there. And it just does it all naturally. I think they're working on GUI support for various different GUIs for getting VMs. OpenStack is almost the default storage. I think it's OpenStack Cinder. It's the project that can use Ceph as a backend file storage. And basically, that's Cinder. Cinder is the OpenStack. Cinder is basically a subsystem that provisioning VMs tell the system, I want a 20 gig hard drive to boot off of. It goes and talks to Cinder, talks to Ceph, and allocates it all, and make sure it's all gets pointed in the authenticated. I'm not sure what others have supported. There's also ways of re-exporting or block devices as you say you could do medium or whatever. And I also use it, like I want 100 gigabytes that runs the database, but I don't feel like going a new drive to throw in my system, so I just allocate a block device and away we go. Ceph, there's a Ceph file system. It's kind of like NFS where it's a shared file system, so two servers are looking at the same file system. You can work on the same file at the same time with all the appropriate positives locking and all that. The main benefit is it's a lot faster than one NFS. I'm not sure on the latest versions, but I don't think it has SD support yet. Which some people that's not a big deal, but pretty much anything else that you would expect out of a Linux file system, support, ACLs, attributes, and all that. Why would you use Ceph? Basically, you need a lot more storage. You're easy to need. Just super. I mean, I looked around for people that are using, I know, DigitalOcean. I think that's their main storage system because they have knowledge. Earlier this year, last year, deployed to their Ceph system. Let's think about that. I'm talking about rebuilding their Ceph system, rack space, a lot of other things out there using for scientific related. If you search through the lists that leads you on this room, so they're getting data off the LHC. I think there's still a subsystem. I'm not sure. I'm not exactly on Ash's name, but you see a lot of folks from IT guys and universities saying, we got research trying to write all this data in our Ceph system and stuff like that. More later, but there's also S3 and Amazon S3 compatible API that you can put in front of this. And so, like, say you've got some application that will talk S3, but I don't want to run Amazon because it's medical data or something or other. I want to run it in the public cloud, I want to run it locally. You can use this. All right, get a little bit more details. Looked at activation. Ceph is kind of the overall name for the system. But the core is RADOS, Reliable Atomic Distributed Object Store. You'll never even know that, you can remember, but you'll see RADOS all over. And basically, that's the core of the system that provides your object storage. And this is kind of what it looks like. We've got these guys here, which are storage, and the M's are monitors, which provide coordination and control. And you have these applications that run on your hosts, and they use this library called LibRados to talk to the cluster. And hosties, I mean, if you wanted to, you can use one hostie, but I'm explaining that. Probably the minimum, I guess, for a real system is 3. Because the way you set up replication, you need to have basically N+1. So if one drive fails, you've got extras. But there's one OSD process for a hard drive. So you throw a hard drive in, there's a new OSD process running somewhere. Drives can be hard, spinning metal or SSDs, NVMEs. SSDs and NVMEs, you got to be careful because the cheap consumer ones break out really fast because of the way Ceph uses them. So if you use SSD NVMEs, you need to find and tell enterprise ones that can handle a lot of RAM cycles. Hard drives, I'm using 5100 RPM size for most of my drives. So if speed's not your thing, not the main reason you need this, you just need bulk storage for something, you can use pretty inexpensive hard drives. And if you go all fancy with SAS, 10,000 RPM, or, $10,000 GPUs and all that stuff. But when a client is pulling data, a client is pulling data out of the system and writing to it, it's talking to the OSD, talk directly. And then you've got monitor. Basically, that's the thing that's kind of watching over the system. It's one that sees all this OSD, this host is now, and starts rearranging stuff in the system. It also maintains the cluster membership, so when a client first starts up, it has to talk to the mod, get some information from it, and then it can start reading and writing data. And it has consensus algorithms for maintaining that data, which is why I always running an odd number, because you don't want to get into a situation where you've got an even number of nodes that get split. They're still running, but they can't talk to each other for some reason. That's one thing definitely want to avoid, which is why you're always running an odd number. Yeah, there's relatively few of them. I mean, they say 3 to 5, I run 3 and 9, just so I get that minimum odd number. But they say 5 as long as you throw down memory and CPU at them to keep up. You don't really need a whole lot more than that. I mean, if you start, getting to that 10,000 OSD cluster, you might need more of it. You can run more than one OSD per node. So if you've got, a system with 4 drive bays, 4 SATA ports, put 4 disks into it, or 4 OSDs, and you're good to go. One thing that's still secure is that under the current stable system, you actually format the drive with the file system. The current recommended is XFS, but it's kind of shifted around here a bit. The stable version is due out real soon now. We've got that thing called Blue Store, which eliminates that file system layer, and OSDs just talk directly to the hard drive. Very efficient. And the other concern about OSDs for hosts, and on all of these, you want to make sure they've got enough memory and CPU. Memory is a big one. When we talk about it, CFFS, I'll explain in detail a bit. On one node, I only have 4 gigs, so it's running my basically charging my CFFS, and every couple of days it would crash and become kind of awesome. I bumped it up to 8 gigs. I'm good to go. It's like, sweet, finally it's that stuff. So yeah, memory is key, and a lot of it has to do with the way Linux is caching data. Because if you look at the processes, well, it's like these processes aren't using that much memory, but they're really dependent on Linux using the memory that's not allocated to processes as it's block cache to improve read and write speeds to the drives. So, I've got some recommendations to talk a little bit about that, but you kind of need to be careful about that. There's a lot of voodoo that goes into sizing your cluster based on what you need out of it. Next one, crush. Control the replication of scalable hashing. This is the key to how it's achieving performance and scalability. And basically, this is an algorithm that's run. This is how it works. So like you got your cluster over here. And we have talked about placement groups. Basically, what happens is that you get your object, you give it a name. This name gets mapped to a placement group, which is basically just how it keeps keeping track of objects. It gets run through the algorithm, pops out 2 or more OSDs, and you see that this placement group, the green 1, 0, is mapped onto these 2 hosts here. And you'll always see 2 or more because unless it's just kind of throwaway data, you can always kind of want to replicate. So you can replicate basically mirror that this is mirrored to each other. There's also this more advanced thing called erasure codes, which is more similar to like what grade 5 or 6 is doing, whereas you're not doubling, well, you're not having the amount of disk you get, or doubling the disk, whatever, how you're thinking about it. It's more like grade 5. You're losing a little bit of storage space to redundancy, but it's not a factor too. And some things people will say you should run free. It kind of depends how paranoid you are about your data. It's like your replaceable collection of digital photos. Kids or whatever. Yeah, you might want to bump it up to 3. And it's just, movies you've done, lost and that whatever reason. Well, might not need to duplicate it 3 times.
Wasn't it Linus who said something along the lines of I use service to it as my backup?
Yeah. This is just a little bit of illustration of how this avoids failures. Basically, it's kind of the same as this darkened over here. It's failed for some reason. Hard drive crashed. Some power plug on. But basically, the monitor knows that and can update it to state. Start replicating it from this good node over to a new one. And you'll see that now the commercial algorithm returns the data of the new version. And depending on how you've got your replication set up and whatever happens, even when it's in the process of replication, you can still do some reads and writes. It just kind of depends on how you configure failover and replication. But that's how it's kind of achieved some of its tendency. A little bit more about the crush. Basically, the crush is a function. Now it's an algorithm. Basically, what it does, it's like you got all your OSD monitors or checking to see what's there, and compiling that. That goes into the function here. So you take your object name, hash it, and that gives you placement group ID, which is basically just integer. On my system, there's like about 1,000 different placement groups. So that's like a 16 number or something like that. Maybe it's 32. Real big. Then you take that placement group ID, put it in this algorithm with placement group ID, and flush the topology. And I won't get into it here, but there's like so much you can do with this. The major example would be if you've got a bigger system, you've got a data center, you've got racks and racks and racks of drives, and you've got so many you get multiple rows. Well, if you really want to, you can set it up so that I've got this data. I don't want it to be both copies to be in the same rack. I don't want both copies to be in the same row. So, in theory, this whole row, if you get set up right, of storage can go out, but there's a complete copy in this other row. or it could be rack by rack and stuff like that. All depends on big. But the default is set up so that you've got like 4 OSDs on a node. You won't duplicate any data on a node. So it always needs another OSD on another node that can take the data. And basically, it's kind of interesting on function. Once you get that data that you get from the monitor, that's all you need. It's like you plug it into the algorithm, you go contact OSD, you can get your data, you write your data. And the only thing the client needs when it boots up is basically needs the addresses of the monitors and it needs an authentication key. Communication in Ceph, it's all, well, it can be completely authenticated, but most people set up with what's at least authenticated. There's no support at the moment for encryption, so you're not going to want to run this across the internet or anything. But it's at least authenticated. So yeah, key properties. There's no storage. You don't have to have any storage on the client. So because it gets all its information runtime and small enough in memory. So your node's a Raspberry Pi. That off the network doesn't even have to have an SD card. It's fast. Every time you want to look up data, that computation takes 5 microseconds. Stable. Basically, if the node goes down, there just need to be some other change. It's like you got 500 nodes. One node goes down, only 1/500 of your data has to be shifted around to get everything back in the proper order. It's not like you don't have to move half the data every time a node crashes. Well, we talked a little about the other domains. That, if you need that, you can say, get 2 rows of stuff and make sure that there's, always a copy on both rows. And flexible, and there's so many ways to tune it depending on your need. And then everything else is layer on top. So if all you needed was object storage, you run monitors, you run the OSDs, and you run your clients. Everything else we need is an actual on top of that we need to run a process somewhere. The main ones, CFFS, your manifest network processing type stuff, the radar block device, that's what allows you to have and stuff like that. Radar gateway, that's basically your Amazon S3, NodeMap, Swift APIs. There's like my SCSI gateway, so you've got to be more systems than one SCSI. There's ways to make that work. Like there's NFS, like client only talks to NFS, so you can make that work. Or you can write your own apps that are talking native directly to the system. And it's actually not too hard. No, it's no harder than writing something for S3. I mean, it's different, but it's no harder. Yeah, this is just kind of graph that helps. You got radars here at the bottom. Most things you use this live radars to talk with it, and yeah, it's got whatever language you want, write it in. It's easy for us. I've written Python access and that's what with it. You get your radars gateway, which run this radars gateway, and then you can write code using S3 APIs, block devices, apparently that's the best stuff to use. Yeah, this is just a little look at how CFFS works. So basically, all the stuff you're doing is on your client. So running down in the kernel, there's this CFFS client that's talking to the Linux VFS layer. And the Ceph FS talks to, for some reason, you see it, I guess, but there's this Ceph metadata in it. And what the metadata is, that's where you get all your information about directory structure, all your posits, read write bits, file ownership, group ownership, all that kind of policy type stuff. But when the client needs actual data from the file, based on it says, okay, yes, here's my file. It gives it all the objects that it's in the data that's talking directly to. So when the metadata lookups can be a little constrained sometimes because you've got this one process here that we're trying to talk to. That once you've got your metadata in terms of directory structure, pretty fast. And then these will talk with the monitors that keep everything updated. Let's just go on the Rails cable client. Basically, is your master. It's talking to the object store backend. Here's your standard HTTP REST API for S3 or Swift or whatever. Primary secondary. Kind of description of how radar slips, KRBD kernel modules, using lab radars to talk to the cluster and such you get it. And there's my base. These 5 HP computers on it, that's my Ceph, or my Ceph cluster.
Where does it came from?
Well, I did the legal DMAC, all this one's to Midwest Computer Recyclers, and they resell them, so that's I went down and bought from there. So it probably didn't come from here because you should push a lot of equipment through them, but
They get all the good HPs. And we take stuff from Midwest Electronics Recovery all the time, so.
yeah.
So then what's the upper rack?
Basically, it's all well,
Tor nodes.
that's a UPS. Yes, they're a smaller one. UPS. These and this. Kubernetes cluster. Which I'm not talking about because I don't know if about that. And then I just got a 24-foot port with a gigabit switch and TV internet gateway. But as you can see, we got 5 HP DC5800s. I mean, 5 years ago, it was just kind of your, it wasn't premium, but it was kind of an upper mid-level desktop. It's got 2 cores, 3 of my does, 24 gigs RAM, 2 8 gig. I've just got one Ethernet card, whatever, 160, I think they're all 160, which is whatever hard drive they happen to have them in there when I bought them from the computer resellers for the OS. And I got 15 drives, 3 are only 3 terabytes, 11, 12 more 4 terabytes. I wanted that deal of list all back, which is awesome. Which is the reason only reason I have one odd one in there, otherwise I'd probably gotten closer use for it. But this is definitely what I spent so far on the system. Paid about $75 each for the tower. Doesn't matter once, no matter mine. Well, I bought a couple. There's one time I bought like 2 at a time, usually give me $1 off. I spent like $30 on 2 upgrades to 8 gigs. This is just instant because I took these out of like some old USB, external USB hard drives. that I had, and I got to have a new one actually.
How hard did you get a weapon? 3 terabyte RAM, 40 ounces.
Oh, that's gosh. Yeah, I guess my math's out there. So
If not, tell me.
I guess I forgot to multiply when I was doing that. Tell me it's a little more than that. But still, it's not like I only got one once. I've never bought more than one of these at once. Just like, okay, I need more storage this month. For $140, click on Amazon, and you throw it in there. That's the nice thing about this, isn't it? Okay, I downloaded some of these. Well, except as you see later. And oh man, I would definitely recommend the UPS. And I've been so lucky that Ceph doesn't really like to be shut down. Well, I like it if you shut down properly, that's fine. But, if you just go in there and throw in the emergency power off switch, then like. So this is Ceph-S. It's basically fan give you a stats box system. Every cluster has a EVD, that's just a minus. In theory, I think I'd be more than one cluster. I think there's a little somewhere in your health. Normally you want health okay, but my metadata switch is kind of slow, and so the systems are trying to talk to it. Get updates and stuff like that. I can't push it hard, whining about it. Most of them, otherwise, no, they say health okay, because mine pretty good. My system should be right now. Then it's got this monitor map, basically a list of monitors in my system. I've got 3 of them. Saying here's the IP address, here's the port. And it's just basically predominantly saying that they're FS map. Basically, we have one NPS. The version I'm running right now, I'm running an active passive system, but I've never gotten around to setting up a second passive one because it's been stable enough. It doesn't matter. Seems to be a stable version. You get on active. OSD map shows over 15 OSDs. Shows it all 15 are up and in. There's like no OSDs can be up or down in or out. Up or down basically is the process there of responding, and in and out is the OSD ready to process requests. Placement group map. Right now there's like 900 placement groups in 4 different pools. There's like 17 gigs of data and like 5.7 million objects. So I got like 52 gigs of raw storage. Yeah, that's mostly all replicated, so it's like 25 gigs of actual data. Other thing I'll say about storage is that you never want to get to this point where you get less than 1 drive storage left. I mean, it's going to whine at you terribly, but you get less than 1 drive storage left and the drive fails. Doesn't matter which one. You're kind of serious to add more storage. Because as soon as the node fails, the OSD fails, it's going to want to start copying the to all the other OSDs, so it maintains its replication. There's not enough space left. And then you can see 895 of them are active in containment, normal state, And then it's also got what's called there's two different scrubs, normal scrub and a deep scrub. Can't completely rely on that scrub to make sure our shade is still up there. That's just basically making sure that all the metadata about what sections the OSDs actually store on the drive is all good. Not actually checking the data itself, or metadata that the OSD uses to keep track of everything. So if you're sitting there monitoring your thing, you see every now and then start putting the scrub on a drive.
So how'd you go, maybe I missed something, how'd you go from 11 4 terabyte drives down to only 52 gigs of usable space?
52 gigs of multi-base.
Meaning,
If you, well, some of them are on 3 terabytes, and you basically multiply 4 times 15 is 45. Well, then that 4 terabytes is for
Oh.
fresh terabytes.
oh, that's 51,000 gigs, so that's like terabyte, okay, never mind. I was misreading it. I was placing a decimal there where it should have been a comma.
And that gives you kind of a little summary of how much data is going in our system. It was fairly quiet at this point.
Can you move drives as well?
Yeah, if you get enough storage. In fact, I did that not too long ago because. The reason I did it was because when I first the system, they were running everything through it. So all the files were on it. But and I forget which release it was. It switched. He set up a new system and everything on a non-root user. But there was a switch to say, okay, just leave it as run. And so part of my kind of cleanup process is to get me ready for the next release. I was going through it and making sure that all that is switched back to a non-user. Yeah. I don't know if you ever trying to do a CIALUG-R 4 terabyte drive. It takes a while. So I just wanted to see this one. Well, no, because the reason I did that was because one drive I said, they're talking about if you got a spinning hard drive, and you set it up, it's actually splitting your hard drive up into 2 partitions. There's the main data partition where you store. There's also a special partition called the journal, which is like the journal, other files in the database. It writes everything to the journal first, then it writes it to the main section. As kind of like the ACID thing for Postgres and all that. But if you want to spend the money on SSD, you put journal on an SSD, and that provides a performance benefit. But I'm cheap. I didn't want to use an SSD for that anymore because I only had one OSD. It's like, well, I can do this. So I wanted to delete that OSD, recreate it without the SSD. It's like we did one free SSD. Yeah. So yeah, if you get enough storage on your system, you can take out a drive. But you've got to be careful not to do that too fast because you take that system on, it's got to want to rebalance data. So and I think going up here is like, this is what happens. It gets a little not happy. I mean, it says health error, but the system was still usable, a little slow because it's recreating everything. Yeah, you can see like 555 live places just fine. But 181 on the remap hearing, basically the copy data around each other. 76 are activating, which means that it's still the OSD is still coming out, and There's a lot, I mean, there's a lot of states, and I'm not sure half of them mean. Yeah, but it's pretty smart. Like if you do something like that, there's tunables you can set. You can see like some of it has weight backfill status. There's only one that's actually backfilling here. That backfilling is the process of copying data back to others. And the tunable system, they only backfill this many OSDs at a time, so that your clients aren't losing out. So that's. But on the other hand, you have a system like that, and it could take days. I mean, multiple days to balance 4 terabyte hard drives.
Balancing accessibility versus speed recovery.
Yeah, but if it's like oh crap, we're not handling it, you vault that up and get it done quicker. But it's a trade-off. How fast you want to develop, you want the clients still, process data.
Can you like pause that rebalancing before it happens? So let's say you got that drive, you got it right there, you just like pause it, pull it out, and ready to resume.
Yeah, because these flags here, and TigerLock was called know-how. Basically, what that tells the system to mark an OSDs out. Yeah, like if I need to boot my node for, like, say, a kernel upgrade, I turn on that flag, I reboot, make sure all my OSDs back up, and then I can turn that flag off, and it doesn't do a major rebalance on me. The basic kind of model is positive a little bit. Okay. So yeah, I mean, if you do root node, a kernel upgrade or whatever, it's like, yeah, there's a way to do it. You just got to make sure not to do it at a time. The system will freak out no matter what. Right. So yeah, it's like same thing for admin node. We haven't only got so many things, so the admin node got to shut the system down. So set that flag, shut the system down, put the drive in, power back up, and then I can initialize the drive. This is just not of how my system is now. And this is basically the default that you don't need to get too creative with it. But basically, it's a tree structure. You just do it there, and it assigns these weights. Basically, automatically it's fine. But if you really need to, you can adjust that. And basically, you assign the weights based on the size. You got the 2.7 one, that's a terabyte drive. There's one other one that's 3.6 or 4 terabyte drives. And you see, right now each of my hosts has 3 OSDs in each of them. And you can see based on the numbering, like I didn't have them all sequentially, basically. You got one this one, and you got one that one, go back and forth. So I have had I think 2 drives fail. Do an actual failure in one time in the system. So, which is why you don't see 1, 2, 3, 3, 4, 5. So, just kind of based on the order you had them in.
So when you have that drive, you have 1 OSD per drive.
Yes, always an OSD per drive. Late, so you missed that.
No, I saw.
Yeah,
the credit with 1 OSD.
The OSD
as I understood it, you can have multiple OSDs.
Multiple OSDs host. There's always one OSD that's talking to the drive.
So there's a process that handles each drive.
Yeah, there's one process that talks exclusively to the drive.
You can't have all.
The OSDs are one-to-one.
Yeah, you can have multiple OSDs
On
per host per drive.
No,
Well,
you could, but why?
I understood it.
But by default.
but you have to use the manual setup. Basically, what you do, your partition, a 2 terabyte partition on this hard drive partition, you set a 2 terabyte partition. Then you get an OSD for each partition.
Okay.
But then there's
Basically,
We'll just do 1.3.
as one OSD per block.
Yeah.
That's best practice.
But yeah, I've never seen any, I mean, if you just want to set up a little test cluster because you just want to fool around with it, it's like you can set it up so you just want to DD, well, you can do that, just DD 10 gigs of space, of empty space, you do that 3 times, and then you run an OSD deployment at that, and then you set it so you only have to run one mod. Yeah, if you're just doing some development and testing, you can set it up like that. But I mean, production use known that runs multiple OSDs per drive. You don't want 2 OSDs trying to fight that drive for access to that drive.
Only unless maybe you had a really, really big SSD or something.
That would be big enough to make that worthwhile.
Okay, but you can have one OSD multiple cars.
No. Okay. Well, again, I've seen people post on a list. Oh, it's like I'm gonna put these 2 drives in a RAID 1 and point my OSD to the RAID 1. It's like, okay, well,
It's not we're talking to because it's going through MB. MB
Yeah.
controlling the drives.
I mean, or we're talking about, oh, I'm gonna put my common storage into the that's cool on the point. That's that OSD, that's
Like, no, get to the point here.
And so you got replication for your replication.
Yeah, exactly. Maybe
my
I put replication.
it's going to be comparing.
For production use, for people to know what they're doing, one OSD process, one drive, and that's it. Because you don't want the system to be fighting for that, bumping that.
Yeah. Some of my end questions were going to be comparisons with DFS because it seems to be.
Yeah, I'm not going to be a lot about that.
The biggest difference is GPU.
Well,
This is CPA, so I mean, with DFS, all of your.
yeah, that's the big thing is that DFS.
Isn't DFS basically object storage at the bottom level?
Yeah, except from
Well,
my
this runs on ZFS, doesn't it?
you could if you wanted to.
Or no, you said XF, sorry.
Yeah,
Is the
the recommended file system when you run the current OSDs is XFS or X4. I mean, in the past, they did Butterfest, but no one's doing it.
well, I hear Razor's rather killer.
Yeah.
Yeah, there's a rumor that even Red Hat's looking away from Butterfest.
Yeah, the only announced that as we're all set, which is came out, they're not supporting Butterfest anymore.
They did like a huge hug. It's still a huge. There's a minor one that just got fixed. There's still a.
Yeah, there's lots.
It's not.
Not really for
This is one of my Kubernetes servers that I set up, and I forget what, I think the server does have an SSD as the main OS, but I'm not sure. But, running Kubernetes, and you know, to make Docker containers and stuff like that. So I set up, I've got 3 different RBDs set up. I'm just looking at one, it's Kubelet. Kubelet's processor manages all the Docker containers for containers. With detail you don't really need to know that. Basically, you map an RBD. Basically, it's in this pool and stuff. Tell this, and the kernel on my client has mapped it to this block device. And you info about that. You see it's the 100 gigabytes, and it's mapped to 25,000 different 4K objects. And that's one reason you don't need big objects. That with Ceph, if you have like really big data, it's usually better to figure out a way to mix with multiple objects rather than getting like really big objects out there. And the way RVD does it, I think when you set up an RVD, you tune that, but by default it makes a 4K object because the default cluster size on computers is 4K, so why not? And if you're like to go and look at the actual objects in the system, all of the objects in this pool that belong to this RVD are going to actually have this prefix. And they've gone through a couple different versions of how all the objects are laid out and features. And you can see that on our level, it's an x-axis. Pretty standard thing. So I've done that for like PostgreSQL databases, MySQL databases, anything you want. That's just what my FFS file system looks like. Shot shows up, but it's all the monitors. And you can see the raw size, 52 terabytes. And in theory, I can use the whole system for all the storage for my Ceph file system. Using 35 terabytes, that's how much raw storage it's actually using. So there's
It's not standard for the redundant data.
yeah. So if you write a gigabyte of data to SFS, to CFFS, you do LSSL, which is 1 gigabyte. That's actually 22 gigabytes of data in storage systems. But I mean, that's the only form for storage. So it's just presented in the way it is. So what's next for my cluster? We get two nodes that are 8 gigabytes right now. 8 gigabytes is the max that you get into those towers. But I'm gonna, it's like there's no stop, so eventually I'm gonna do it. Well, depending on some other stuff. 12.2 is due. I don't know if it's an exact date that they're in release candidate phase now, so I'll expect a month or two. I'll probably wait for 12.2.1 rather than 12.2.0. But the main thing I'm looking forward to is the store. And basically, that's a feature where I don't any longer need that XFS file system on top of my raw drive. Or if you just talk to the raw drive itself, and passes that later, which is the big thing is efficiency. That it will also check some all your data when you do the storage. Would be nice. But any other upgrades? Seriously, I feel like 115 amp circuit in my office there that might have 2 megabyte switching around up there. It's just 115 amp circuit. And circuit's pretty full right now. So
Feed it 220. Still 15 amp, you know.
well, the other thing is like I'm using all setup works right now. So they have one OS drive, one OS drive, and 3 OSDs. That's 4 setup works. That's all they can.
You don't have any expansion cards or anything?
Well, I mean, they could.
Do they have PCIe or are they just PCI?
Okay.
Okay, so yeah, you can do that.
Well, the other has like days too.
Have you used up your 5.5 inch days?
Well, I just physically, well, look up on
USB enclosures.
The east things.
Yeah, yeah, those guys.
Replace it with things that 5 total in there because.
Yeah, depending on if you get one that's made for the 3.5 inch versus the 2.5 inch, you have enough.
No. On the other hand, the memory in the servers is limited to 8 gig. So it's like, every time I won't add more storage, really shouldn't be adding more memory. So,
I think what you should do is you should play around with a Ceph instance that runs purely in RAM. It won't have that much storage space, but it'll be really, really fast.
But that memory requirement, is adding memory as your storage, is that add drives because of OSDs?
Well,
Or is that density? Like,
Well,
at the bottom you say replacing
yeah,
trees with larger.
as you add storage, storage, and hard drive space, you really want more RAM because each OSD needs a lot of memory to manage all metadata. Plus, you want extra so the Linux cache through the bottom of that.
Now, does it
Support both? Yeah, so like I was saying with my the server that ran my MDS, it's like when I only have 4 gigabytes every couple days, sometimes several times a day. Usually, watching a movie or something, it would freeze because it didn't have enough memory. Maybe there was a memory bug, who knows what. But ever since I've upgraded that to 8 gigabytes, it's been great.
So,
Sorry.
I was going to say, does an OSD running for, say, the 160 gig drive versus an OSD running for 4 terabyte, is one of those use significantly more memory than the other, or is it kind of like an OSD?
Significantly, but it's going to use more.
Okay.
Because it's got to keep a lot of memory information in memory to map all that data to the. And I don't know how much it uses, but yeah. Well, I could look. I just never have.
So with the new Blue Store, will you still have the OS caching built in, or?
Well, Linux caches data at a couple levels. At one level, it actually is caching the data at the raw block. Because like if you do free, and there's several different columns we can do when we get to the demo section. But there's several columns, and there's one column that says how much data you want to cache raw blocks that came off the hard drive. And then there's also caching at the file system layer, where it's caching directory metadata, etc., to make making LS-L faster. So there's a couple different levels. And by going to the Blue Store, where you don't have a file system there, you don't have Linux caching all that information in the file system. So it frees up. For everything else. Yeah, like short term, like I said, short term, if I really need more data and I just can't, I don't want to delete Game of Thrones or whatever, I've got the 3 terabyte drives. I've been buying 4 terabytes because that seemed like the sweet spot in terms of number of terabytes I got per dollar. It's a little higher than that, and per terabyte gets a little more expensive. But, that's part of my short-term information.
And I assume you do that by upgrading at a time?
Yeah, basically what I have to do is I'm going to have to make sure I've got 3 terabytes of free space and the rest of the system. Shut the system down. Well, first I tell the system, you just mark this node as dead, and then it starts capping all the data into the other nodes. And then you can shut the system down, pull the drive out, plug it in, reinitialize it, and then it starts copying it back. So it's a slow process, but it's fairly straightforward.
Well, okay, if you were doing 1 drive at a time, you upgrade the Ceph on that PC, and so that it had the new version of it. And then you take all the data off.
Time to upgrade to 12. I'm running like 10 to 6 right now. When it comes time to upgrade to 12 too, it's an online upgrade, but you don't want to waste any time either, because you just don't, because you just want to make it all upgraded as soon as possible.
Right, but I mean, will it do on drive
No.
raw
No.
convert?
I would basically have, it's like one drive up and then you have to.
And then the
Yeah,
the new OSD process
Yeah.
would then know whose store exists and how to deal with it, and then you want that drive for the booster instead of.
That's actually what I'll have to do is that once I'm upgraded, up to 12.2, basically say, tell the system, okay, delete all data off this drive. Wait for it to rebalance. I can reformat the drive, use the blue store, and copy back. And like I said, it's I mean, moving data, 4 terabytes of data across 1 gig takes a while. Especially if you're concerned about other systems having reasonable performance, all that's happening. And usually, it's usually 26 to 40 hours. That's our right? I usually give 36 to 48 hours every time I do that.
How
I
good,
mean, if I spent the money on like 10 gig networking and yada, 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 I could shorten that, but for my purposes, it's not.
If you put 10 gig networking in a Core 2 machine, you're crazy.
Well, yeah. But, I mean, longer term, probably some things I would do is replace these DC headers. I mean, they're rock solid. I mean, because when DMAX sent them to them, it's not because they were broken. It's just we bought new ones because they were that old. But it's my experience, like, once you get past year 2 or 3, it's still running. It's going to run forever until it looks off your head. I mean, there's still some, in a room just across the way here, I've got some Nortel 450 switches that I installed 20 years ago. They're still running. And yeah, there's something like that. I mean, once you get past that burn-out period, a year or two, it seems like it's forever. But on the other hand, I think they're efficient.
and eventually there'll come a point that Raspberry Pis will outpower them in computing power.
Yeah.
It might be 20 years, but
Another question.
Yeah, Raspberry Pis are the 3. Of course, it might be close to have more CPU power on these. But everything else is passing out of yeah, at some point, I'm gonna replace these C5800s with, some nice efficient rack on servers. And at that point, I'll probably go with something and get more than 3 OSDs into. And really, at some point, I'm kind of getting the electrician to upgrade. Not just for this. I mean, I've got a 15 amp circuit that's feeding my office with this, plus who knows what else. I have to track all that down. But in my garage, I've got some 15 amp circuit. I'm a woodworker. And I mean, literally 2 weeks ago, I was building some stuff for marching. And I had some other guys come help me. And so we were running an air compressor, running some fans, running a shop vac, and an air saw, and blue circuit, pop circuit.
just run an extension cord.
Yeah. Well, I mean, it's not bad at all. There's other things I want to bring an electrician to, because the panel in my basement's full of stuff. At some point, I'm going to bring an electrician to do that. I'm okay with some analog stuff, but at some point, it's like, no, we're talking mains power here. It's like, okay, someone to come and do that stuff. But yeah, it's like I said, I haven't measured the exact temperature of my electrical bill, but it's definitely going. So. Yeah, and actually, what was it, a couple months ago? An American sent me a letter saying, gee, you use a lot of power there, don't you? Yes, I do.
Are you sure you're not growing things?
Yeah,
The Fed's not gonna have. It's
actually not super funny because, it didn't show the picture, but off to that, kind of a desk set of what my son, he's got his PC down there, so game without disturbing the rest of us. But he's down the other day and it's like, Dad, is the reason that room is so hot? It's all the computers you got in there? It's like, yeah. Yeah, that room is noticeably warmer than the rest of the house. It's nice in the winter, but that's not shocking. So you want to run your own stuff, Buster? Maybe you're a big business, or maybe you're just crazy. The first thing you gotta do, sign up for the Ceph users meeting list. For a lot of reasons. One, I'm not going to resource on how to fix it because I'm getting through by this my team based on what I find out here. But when they put out a new release, and they've got really good release notes, you're going to want to read those. I mean, everything else you just upgrade, who cares? But Ceph, read those release notes. Because they usually, even on minor releases, there's sometimes manual things you have to make sure. Yeah, take this midwise flag there. Not good, like make sure that it does, but at least notes. And they said when you upgrade to 12.2, make sure that turned on. So it's like when I'm doing some main fallback, I made sure I turn that on so I'm ready. And that was just a minor one, but you know, every now and then when they put out a release, there's kind of a new thing. You know, some manuals change, make sure, or make sure the state before you do an upgrade. You know, make sure you upgrade this or that, so on and so forth. You could really screw yourself, you know, read those release notes before you do an upgrade. Even just one minor version, so I always gotta look. The other thing is like, I always wait a couple days because there's people out there that got they do an upgrade and then report back, I get one break. Oh, died because of some bug or something. So you always wait a day or two.
Everyone else you can for that.
Oh yeah.
Unless you want to be the guinea pig, you let others do it for you.
Yeah, unless you get, you know, it's just a test system, but you don't mind screwing up. Let other people get it, because I mean, literally, I've got all my digital photos out there. I was organizing them there earlier this summer. I've got like 30,000, 40,000 digital pictures out there. I go back, I mean, decades. And I've got scans of some like older pictures of relatives that date back to pictures were first invented. I don't have the original.
You have backup?
Well, yeah, of course.
Oh, okay.
Oh yeah, I mean, that's another part of it, yeah, you wanna make sure you get all this data backed up somehow. Yeah, it's like, I've got data on the system, so it's like, I can't afford to be guinea pigging this for someone else, I'm gonna let someone else do that. Yeah, great, maybe you just got things out there, you need crashes, so people use them re-download, it takes you, it's annoying, but, you know, I don't know. So it's all what you got. But especially when you're starting, and you're just new at this, you're not the Ceph guru. It's like, hey, read those release notes, let someone else get you. Yeah, and stick with LTS version, whatever operating system. I'm personally running CentOS, which is what I think you should run. I mean, if this is, you know, if you're doing this as a business, I'd probably go with Ubuntu for now, service contracts in place. But it seems like most people are running CentOS for now or Ubuntu. Some people are Debian. Mainly because like RHEL Ubuntu, you get that extra support for the header to call to fall back on. It's not, you're not like updating kernels every day to realize what it is.
Can you do bonus upgrade? Keep your Ceph data in place?
Oh, yeah. reinitialize a disk with no SD. Yeah, we can look at that later. Yeah, all of the data. Well, there's basically two things that the OSD come up with. Needs to know the location of the monitors, that needs an authentication key, and then it needs the data that's on the OSD. And I mean, you got one config file and DC/stat or whatever. You know, as long as you create that, and as long as nothing's affected the OSD, that's pretty easy to recreate. So yeah, if you're always trying to fail, that's not too good from that value. Yeah, because I can come on these nodes, I can actually back up the OS itself, because I know I personally use install as a configuration management system, which everyone should be doing that one machine. So it's like literally in probably 2 hours, I could boot up a system from bare metal and have it running. Probably less than that. Then also Ceph itself has LTS versions. I said, explain where Ceph comes from. It's basically short for cephalopod, which is like amplified squid. So they name all the releases based on type of octopus or squid. So the current one is dual, which is called 10.2 something. That's what I'm on right now. Should be a month or two, and they'll be releasing the LTS one called Luminous. Something like Kraken.
Yeah, you don't want bleeding edge storing your data.
Yeah, it's like one of on the Fedora van list, there's some guy talking about, oh, let's upgrade or what it's in. Well, Fedora also produces RPMs and CentOS, Apple packages and maintainers. Oh, would anybody mind if we upgraded from 96 or up to 1? That would be a problem because if you look at the reasons really carefully, to upgrade from that, you have to upgrade it to this, which is a manual step, because you have to shut it down. And you have to upgrade to this version, make some changes. You have to, yeah, it's like, but it's pretty nice because Ceph, the company has their own repositories that you can install from. You need and all that. I guess I didn't include it, but you can run OpenSUSE too, the LTS versions. Most people on C are relevant to. But yeah, but they've got separate repositories, so you want Jewel, you can have a Jewel repository until you're ready to switch.
So they're going on hot cases where odds are development even though
I don't know that that's exactly for sure. But I mean, if you go out and look at the release notes, you can all find out which is which. And like I was saying, dedicate your machines that don't want anything else on them except for maybe monitoring software. Because they want that memory, that CPU. You run other stuff on, you need to cause reliability for people involved. They both see that, they both suck. And it's also it's just a chicken problem, really. Yeah, like careful with these notes. And also there's a lot of stuff that's got to get configured in a certain way. So, get your hardware together, install it, see if it's working the way you want it. Repair it at some point. It's like, oh, it's too much. Just wipe it and redo it. Get it to a different one that's a little better for what you want. Yeah, this is the other big thing. Ceph is not set it for you. You just want few terabytes of storage that you don't want to worry about, go buy a Drobo or a Synology or something. You gotta watch this sucker. If you lose a drive and you don't notice for a few weeks and it fills up, and you gotta have a sucky weekend. Oh man. Because yeah, I mean, there's a lot of stuff that you catch it, early, like, oh, it's easy fix. But if you let it go too long, it's like,
So the monitor doesn't just raise flags?
yeah, it will. I mean, you can sit there and type this up fast and you'll see all the problems.
There's no plug into the monitoring.
Well, not. That's something.
You could write like a wrapper script to shoot you an email. Let's see.
Yeah, there's a lot of solutions for magnetics or whatever my mom want. That's email, but that's also, I mean, that's something else you get to that page of magnetics, you just can't ignore it. But yeah, that's the recommendation. It's like, sooner or later, hard drive's gonna fail, you're gonna download too many movies or whatever, you don't want to play them, so just kind of have your mind that every couple months, hard drive time. And I mean, it's nice to put it back for, I mean, it's your shirt, guys go to college, so please be careful with that. Like most of us are around that, $20 for a hard drive. It's not as big as it used to be. Questions? I mean, personally, I love it. I mean, the reason I set up in the first place is because way back when I started setting up meeting servers, we got a lot of USB external hard drive. Cool. That's coming up. Okay, let's go ahead. Okay, I gotta get a USB 3 card and run these out. That was like, yeah, I'm gonna find something that, okay, it's gonna be, what I was looking for, I want something that's easy to expand. Just buy a hard drive and this is the fight. And if you got Drobo with Synology, once you get your 5th hard drive, it'll really up from there. And it's like, I mean, here it's like I'll never max this system. If I'm able to spend money. Yeah. So it's like okay, there's a cluster FS that's got certain limitations. I mean, you can do a lot with cluster FS, but it wasn't quite what I was looking for. So that's why it's like, well, this is like really cool technology. I don't know how to do it. I mean, it's the same reason why they did all local stack. It's why they've got, a bunch of servers that are doing this is cool stuff. Like, they're not paying me here to do this. So it's like, I want to play with this and figure it out. So it's like, get decent income, like spend some money on this. Yeah, nice thing too. I've got all the storage. It's all there. At my house on the fastest side of the internet. Because you can get a lot of storage out of Amazon or whatever, but on the wrong side of the slope on the internet. So I want something fast and here. It's like not too big a hassle, so I need more space. But and downsides, you just can't, you gotta keep going at it. Every now and then, I'm just go see what I'm doing and make sure it's happy. You guys want to go for some demos or not demos? And just do a few quick examples of this at dinner.
Got no problems with some demo time.
Yeah, we'll do
I mean, we came all this way. Personally, I'm just right down the road, but there's the reason why I like this location. So what is the current status of the makerspace? Is it still month to month?
Month to month.
What do you mean by month to month?
Before the day ends up.
Yes. Yes.
It's moving 70 feet. Big move. Good move. Theory.
But
Yeah.
It's kind of like that video game joke.
It is, and we're totally at the liberty,
Yeah,
at the mercy of the.
The owners. That makes sense.
Yeah, this is a lot of my cluster. Basically looks almost like slide board is snapped that earlier. Yeah, but sort of bitwise and require dual OSDs. They said it's just preparation for the next upgrade. I don't know what sort of bitwise does, but they require two OSDs just make sure that the OSD running over the software doesn't end up in the system and can't screw things up for me.
So I did a quick search on sort of bitwise, and it sounds like it's an internal sorting method that's kind of exposed out for backwards compatibility.
Yeah, I never looked at it. It's one of those technical things that I'm sure makes sense once you dig into the details, but.
Their answer was just make sure you set it to yes.
Then there's the Ceph -W. This kind of gives you a live look at kind of going through the watch list for rebuilding. Then you see there's a lot of data going. Not super active right now, but you see like varies, kilobytes a second. If you're busy downloading or uploading a bunch of stuff or whatever I can get. I'm limited by the 1 gig Ethernet that I have. Really wish I like to update to 10 gig with right. Yeah, I've seen up to several megabytes a second. On there. I actually like here just popped up just coming in on LC. That's into 8.EC. That's a placement group name looks like it's pool number 8. Placement group EC, which are remember that stuff.
So generally you got enough going on. There's never a time where things are just idle.
Well, I've got servers and clients that are always running in the back end off my Kubernetes cluster or something going on.
But this is probably as idle as right now.
Yeah, that's pretty quiet right now.
How long does it take to RMRF?
Long period of time.
You don't know that? Why not?
Demo. Just give us your IP address. Open your app.
Well, yeah, like I said, because I did as part of my preparation, I was the CIALUG on the whole drive, and I didn't time it, but that was many hours I had a day just doing CIALUG on every clock. Unfortunately, I don't have very fast drives.
I'm wondering if that's your slow, it's not necessarily your network port speed.
There's a lot of factors into it. I mean, except one, most of my drives on 500 RPM, so that's one factor. I'm sure my SATA bus is not super fast. Only at 1 gig. It's really, like real production system for the base system. You're supposed to have two 10 gig interfaces. One interface, the network is dedicated to FLCs to talk to each other. And the other interface to the clients to talk to the OT. So, I mean, I'm not really behind the game because I just got a single 1 gig interface. But, I mean, for me, for my needs, performance is acceptable. You know, I'm not one of these speed awards, but the main thing I want is bulk storage and it's fast enough so I can stream movies off it. So, good. After this radar command, this little command line utility for actually, messing with objects. So you can see I've got 4 rules right now. We have this Ceph metadata. Ceph uses actually 2 tools. One that has all the metadata, all the directory structure, file ownership, and then it's got the data pool that stores all the actual data that is in the file. We have one called RBD, that's where Rails block devices live. And we got one called Tech Photos. I was messing with the software to. Because right now all my we got all my digital photos on Ceph right now, and be able to put off by ear basically and stuff like that. But I just messing with the software too. Let's see what happens when I take that and then it later on next. It's looking at a finished project. So if we do this, very cool. Just quickly, and you see, I created a pool. Basically, when you create a pool, it wants a certain number of placement groups. All false and tuned, I can't remember what I got it set to now. Like it's like 100 placement groups. You see, I just created this pool, so I need placement groups. So you see 895 active clean, 58 that's created. So basically, it's telling OSDs to go out, I need these pools, go create all the metadata on the disk that you need to manage these new placement groups. 6 are creating peering. That means that tick to be created, and OSDs are targeted and they can make sure everything's set up. Yeah, this is a small operation. So sometimes fast. This just depends on how much data you move around. I mean, creating a new pool, there's some metadata that's got created, but it's pretty quick. You want to see something real crazy? They've got recommendations on the number of placement groups you should be using. And when I first set up, I had a number of placement groups, but as I grew, I needed to basically split. One placement groups, oh man, you want to see the data chart. So let's see what objects are in there. Nothing. We just created it. Do that. The whole crap of objects in there. And you can see, like we were talking about, that prefixes. There's like the prefix RBD, 600, etc. All that. So basically, you can see like actually see one up there. Yeah, basically, there are a lot of objects that long as RBD have a RBD prefix. See, that's how us kind of keep track of everything, right? And see when this is the one I was creating, and decided that I uploaded my picture. I was gonna have this little prefix original, and then I took the shot 256 of the image, and then we got stripes. Just put the suffix on 0 for the first stripe. So on, see, like this is the 36 stripe of whatever picture that is. So you just figure out ways to break whatever data you want into the multiple stripes. It's a little, I don't know the outcome size is, but it's kind of the outcome size for an object. So you want to kind of, I think I went for like 64 megabyte objects. Brightness. I mean, if you're real serious, you probably want to use one just to figure out what ideal.
And those are best determined internally based on what your data is and what your needs
Oh
are.
my God. So once you get a list and see everyone comes up, how do I like recognize performance of my Ceph system? Like, well, you can maybe a bunch of money to come on. Big question.
If you're asking,
Well, there's so many things. The hardware, how many LSPs you know, how much memory is there? What type of hard drive is it? Spinning Rust or SSDs? What you know what topology might claim. You got 10 gig uplinks. Does that go to a top rack system? I want to get one 10 gig link to the rest of the racks or whatever. And then the data is all set at best. It's like there's a so I mean it's just that's like super complex topic. You can get some hints from the meta. But I mean, if you're really serious about it, either you dig in, you set up a lab with your workload and testing, or you hire somebody in kind of maximize performance.
So you tried like 64 megabyte objects. Decided you didn't like it. Is it easy to change that, and you have to basically delete it, start over with whatever?
Well, the way I set up my system, I'll show you one thing. Commands. Because when I was running my software, basically when I uploaded, was try to put in the content tag, the JPEG, raw file or whatever. Put in the hash algorithm that I'm using. But then I also put string file. I put the hash in there file and uploading. The name of the file under the object based on the hash of the original image. But I also still the hash of the actual object on upload. So I can double check if I'm down the whole thing I have that. And then straight count and all that. But when I needed to the size of the stripe, the way I set it up basically, you gotta go delete everything and re-upload. But if you had a different, if you were doing it differently, maybe you could just go there right in the object or whatever. Well, and another thing is on this particular flow, regular coding basically means that you only pay 1.5 times for penalty instead of 2 times. But that means the objects are like once you've written the object, you can delete it or read. So that's that. I mean, that on 12.2, that's two notation. Yeah, remove it. So it all has to do with how much you can capture your data. I mean, if it was just a regular replication tool, you can change a single byte if you want to. I don't know if you can do the command line utility, but I think you can using directory byte all the time. So. So I just put hello into the topic name hello. So LS is my hello. And there it is. Yeah, it's basically, it's basically what you've done is fancy, key value database. It's like super scalable. Like I said, from that, you can build a lot of stuff. So there's one process with the monitor. A little bit of RAM, actually, not sure. And actually, in real production environment, the monitor can be your own separate physical node. You wouldn't run because you wouldn't run. There's my posty. Like some process there. And you can see like here, I'm not quite in. Being able to already see this first one is running the one I have just over, but this one, the second one here, putting in the user stuff. And a little bit in memory, but not too much. Yeah, you see, before you fit the memory and use quite a bit. There's nothing else you want to see, I think I'm done.
Thank you.
Yeah.